So continuing to look at slope today, the first question is, which is steeper, a line with a slope of 2/5 or a line with a slope of 5/2? Which one is it? Anyone? I'm sorry? 5/2. How do you know that? It's bigger than, yeah, 5/2 is greater than 2/5. So that's steeper. All right, then it asks you to compare these two lines. What's different about the two lines and what is the same about the two lines? Let's start with what's the same. What's one thing that is the same? I'll take a volunteer. So what does that mean when you say they start at the same place? What do we call that point?
Cross the y-axis at the same time.
Which is called the
Y-intercept.
y-intercept. They both have a y-intercept of 12. What's different about the two lines? Again, someone raise your hand. I'll take a volunteer. Yes, sir.
The slope.
Could you be more specific than that?
The slopes are opposite. Like
So let's be even more specific. What is the slope of A?
the lines are like
What is the slope of A?
y it's two over one.
The slope of A is 2/1,
Yes.
and the slope of B?
1/2.
I don't think so. Yes? Yeah, it's -2/1. The line moves down instead of up. Now, if we were asking about steepness, which one is steeper?
A. Both are the same.
Yeah, they are the same steepness. They're the same steepness, just that one of them is going up while the other one is going down. So on this it says, each line on this graph describes how much money a person has in his or her wallet over time in days. Explain what's happening to the amount of money each person has. Be specific. So for person A, what's going on?
They got a paycheck.
Well, let's be way more specific than that. Yes, Ben?
Their money increases by $2 every day.
Yeah, that's a good way to say it. Well done.
Yes.
Their money increases by $2 each day.
Person B is losing $2.
So say it again. What?
Person B is losing $2 each day.
Yeah, for B, their money is decreasing by $2 each day. So, I don't know, maybe they're buying something each day that costs $2. Or maybe person A is a bully and they're taking $2 from the other person each day.
Or maybe they're entrepreneur
They're an entrepreneur. Maybe they're selling them something.
and then they make profit and then B bought the product and they lose money from it.
Yeah, there are lots of things that could be going on here. So to describe how person A's money is changing, the unit rate slope amount represents the amount that is added each day. Since the money is increasing, the slope is positive. But what should you do when the value is decreasing?
Get more money.
How should the decrease be reflected in the rate?
Negative.
Yeah, the slope is negative. And we've already found the slope of each line. For A, the slope is 2, and you can just leave it as 2. You can write it as 2 over 1. Either is perfectly acceptable as far as I'm concerned. And B, the slope is negative 2. All right, so let's see if we can describe each of these lines. Is it increasing or decreasing, and quickly or slowly? What about A?
Increasing.
It's increasing, quickly or slowly?
Quickly.
Fairly quickly, yeah. What about C? It's decreasing and fairly slowly. What about line B?
It's not increasing or decreasing.
Yeah, it's neither increasing nor decreasing.
What speed is it?
I'm sorry?
What speed is it? Like,
What's B what?
speed. Like, or how fast is it going?
Well, this is money, so I don't know why you're asking about speed.
Or
Like
how
increasing
quickly-
quickly, decreasing slowly.
So this person is neither gaining money nor losing money.
They're saving.
Which one?
They're saving.
Yeah, but they're not ever increasing the amount that they have.
They're saving, but it's not payday yet.
So line B is different from the other two lines. As the X value increases, what happens to Y?
Stays the same.
It stays the same. So as a reminder, slope is a comparison of the change in Y to the change in X. Let's pick 2 points on line B and write a slope ratio for B. So I'm going to use this point and I'm going to use this point. This point has coordinates 2, 4. This point has coordinates 5, 4. What's the change in Y? From 4 to 4, how much did it change?
1. A 0.
0. What's the change in X?
3.
3. And what's 0 over 3?
0.
0.
Oh, yeah.
While we're talking about this, I can't remember if it's going to come up later or not, but let me ask you about this. What if the Y went up 5, but the X didn't change at all?
Same thing. 0.
No.
It's 5.
No.
Negative 5.
No.
3.
It's not 0. Okay? This is something you may have never seen before. So just hang on. Just hang on. All right. Let's think about this for just a second. When you have a fraction, if I tell you that you have 2/3 of a circle, that means the circle has been broken into 3 equal parts and you have 2 of them, right? So that's 2/3. The bottom number tells you how many pieces you have. So if you have 0/3, that means we have sliced this thing up into 3 parts that are all the same size, and we didn't give you any of them. How much do you have? You've got nothing.
No pie for you.
Okay? Yeah, no pie for you. So here, we've broken something into 0 pieces. Is that possible? No, because it starts off as 1 piece. You can break it up into more, but you can't break it up into less. This is undefined. It's not zero. It's not no solution. It is undefined. In all of math, there's pretty much one thing that you can never do, and that's divide by zero. Everything else, even some things that you may have been taught in earlier classes that you couldn't do, they can all be done. But you can't divide by zero. So when you were really little, you may have had a class where a teacher said, oh, you can't take 5 from 2. Yeah, you can. You just get -3. You may have also been told, have you guys learned about square roots? Do you know what a square root is?
It's like what you
It's like two of the same number that multiplies.
yeah, it's like we're
A square.
it's like
Okay,
reverse
so like the square root of 25 is 5, because 5 times 5
is 25.
is 25.
So that means the square root of 81 is 9.
Yeah, the square root of 81 is 9. That's exactly right. At some point, someone may tell you, you can't take the square root of a negative number. That's actually not true. You'll learn later on ways to take the square root of a negative number. But much like when you were subtracting and you had to get a negative number, which was a new kind of number you hadn't thought about before, with the square root of a negative number, there has to be a new kind of number that you probably haven't ever thought about before. All right. So, what are the growth rates for A and for C? What about for A?
1 by 2.
It's what, I'm sorry?
2 goes up 2 and right 1.
All right, so that's 2 over 1. And what are the units?
Units. Dollars.
Dollars per day.
Dollars per day.
Dollars.
Give you a second. See if you can find the one for C. So what's the growth rate?
-1/2.
No. Try again. -1/3 dollars per day. That means you lose $1 every 3 days. Okay, now we can also express these as unit rates. For A, it doesn't change anything. It's $2 per day. But for C, that would be, we can make that -1/3. We can just leave it that way. Can you write that as a decimal?
0.3 repeating.
Very nice. 0.3 repeating dollars per day. So up here on this one, we could have written C as -$1 per every 3 days, right? That would be the growth rate. All right, let's move on to the back.
So if you get undefined, can you multiply it by like 0 and get 5 again?
No. Yeah, you can't do an operation. That's a good question. You can't do an operation with an undefined number.
So just say undefined.
It's just undefined and yeah, there's nothing you can do with it.
Are we gonna have undefined on the test?
I don't know. I haven't looked that far ahead.
Is it gonna be on the final?
I don't know. I haven't looked that far ahead. I just figured I would drop it in now so that if we get to it, you'll have heard of it once before. All right, so to prepare for biking long distances, Antoine has been trying to keep a steady pace as he bikes. However, since his hometown has many hills, he ends up biking faster and slower during different parts of his ride. So, to track the distance and time when he travels for the triathlon, when he trains for the triathlon, Anton downloaded an app for his phone that tells him how far he has traveled at specific time intervals. These times and distances are shown in the table below. All right, so according to the table, does he appear to be traveling at a constant rate?
No.
Wow, y'all jumped on that quickly. I want you to give me concrete proof.
So when you go from
Whenever,
3
Wait.
minutes, when it's
when you go
half-
Wait, hang on, go ahead.
3 minutes is half a mile, which is a growth from 0 to 3, which is 3. But then you go from 3 to 5, which is 2, but you go another half a mile, so that shows it's not constant.
So let's look at this. From 3 to 5, how much time had elapsed?
2 minutes.
2 minutes.
Yes.
How much distance had he gone?
0.5.
So what is his rate?
2 minutes equals 0.5 miles.
That's not a rate.
Y equals.
No, I don't want an equation. The rate is the slope.
2 over 0.5.
All the way around?
0.5 over 2.
So it's 0.5 over 2. We're not really crazy about that because it's part decimal, part fraction. So I'm going to double the top and the bottom and make it 1 out of 4. He's traveling at 1 mile.
A quarter of a mile for.
1 mile every 4 minutes or a quarter of a mile per minute. Either way you want to think about it. On the next interval, this is now 3 and this is 1. So it's 1/3. And those are not equal, are they? Well, I'm not trying to solve something. They're just not equal to each other. So the answer is no. So I want you to take a minute and graph those points. All right, everybody got the points plotted? Anybody need a little more time? All right, so the next thing we're going to make is what's called a trend line. Later on, you'll learn more about how to make these more specifically. It's called a line of best fit. Don't worry about that right now. So we'd like a line that best fits this data. Notice that 0, 0 wasn't in there, so I'm going to erase that point. I put it on there so that I could see where the origin was. Bless you. Bless you. If you want to make a really good trend line, one of the best things you can do is find the middle of the data. And by the middle, I mean the average. So I'm going to add these together. I'm going to do this in a different color. So it's 8, 16, 28, 38, 44, 63. And there are 1, 2, 3, 4, 5, 6 of those. So that would be what? 63 over 6 is what?
10.5.
10.5, thank you. And then for the times, it's the 1, 2, 3, 6, 10, 11, 17 over 6. That's not nearly as nice, is it? 2 and 5/6. So almost 3, right? All right, let's see if we can plot approximately where that point is. So 10.5 and 2, but not quite 3. It's right about there. So what I'm going to try and do is draw a line that'll go through this that's as close as I can get to all these other points. If you want to grab a ruler and try it, please do. They're right up there on the table at the front. So draw it in and draw it long enough to where it's going to cross 10 minutes, or 10 miles rather. So I got at least that it would take about 30 minutes. Did you get something close to that? 27? Mine's probably not quite as straight as it ought to be. All right, let's leave that last question because everyone's would be different.